What's up, interweb? Okay, today we're going to talk about complex numbers. You remember last week or so, we said that the square root of negative 16 is undefined because nothing times itself is a negative number. 4 times 4 is positive 16. Negative 4 times negative 4 is 16. If you said negative 4 times positive 4, those are not the same numbers. So remember, what does the square root mean? What number times itself? But we have to have a way of dealing with this. And we have imaginary numbers. And we use a lowercase italicized I, kind of a cursive I. So what we do here, if we have the square root of negative 16 equals the square root of negative 1 times 16. Okay, and that's how we can get this to be positive. Now we know what the value of square root of negative 1 is. The square root of negative 1 is I. And we can also rewrite this. Remember, negative 1 times the square root of 16. We can write it either way. It doesn't make any difference. Now, the square root of negative 1 is I. And the square root of 16 is 4. We typically put the 4 in front of the I, but it really doesn't make any difference. Okay, so do another one. Square root of negative 36 is the square root of negative 1 times the square root of 36. So that is 6. Square root of 36 is 6. The square root of negative 1 is I. So that's all we have. Okay, now what about this? If we have the square root of negative 48 divided by the square root of negative 3. Now remember, when we want to take the square root of a number like this, we want to factor the 48 into two numbers where one of them is a perfect square. And that's going to be negative 16 times 3 divided by the square root of negative 3. Right? Right. Okay. Now the square root of negative 16 is negative 1 times 16 times 3 divided by the square root of negative 1 times 3. Okay, now the square root of negative 1 is I. Square root of 16 is 4 times the square root of 3. Okay, now down here we have square root of negative 1, which is I, times the square root of 3. Now anything divided by itself is 1. It's just eliminated. Now, the i's cancel each other out. Square root of 3 divided by the square root of 3. We don't know what that is without a calculator, and we don't care. We know that the square root of, any number divided by itself is 1. So it just cancels each other out. So our answer is right. Okay. Now what if we have this? Square root of negative 32 divided by square root of 8. Okay, what are the factors of 32 where 1 is a perfect square? Negative 1 times 16 times 2 divided by square root of 4 times 2. Okay, excuse me. We know that the square root of -1 is I. And once you take the square root of it, of course, it comes out of the radical. The square root of 16 is 4, square root 2. And again, excuse me, the square root of 4 is 2 times the square root of 2. Okay, square root of 2 divided by square root of 2 cancels. 4 divided by 2 is 2. All right, just reduce this fraction. So we end up with 2i. If you have a hard time with the fractions, see if you've got a child, a third or fourth grader that can help you. That's what I always have to do. Mm-hmm. Okay, the other part of this is I squared is -1. Because if we have this, if we have I equals the square root of -1, if we square both sides, then I squared equals a square root of -1 times itself is -1. Now, all this misery here about putting a -1 here is really not all that necessary. I just did it to kind of show you. If you've got a negative number on the inside of the radical, all you do is pull out an I rather than you can do all that if you want to, but that's okay. For instance, if we had the square root of -25, the negative we can pull out an I, and square root of 25 is 5i. Okay, instead of doing all that -1 misery, you can just do that. Okay, now remember, I squared is, where is it? I squared is -1. So if we have if we have 2 plus 3a times 2 minus 3a, these are conjugates, which means the linear term, the middle term, will be eliminated. So we take the 2, multiply it times everything over here, distributive property of multiplication. So this equals 4 minus 6a, okay? 2 times 2 is 4. 2 times -3a is -6a. Now we do the same thing with the 3a, everything over here. 3a times 2 is a positive 3a, so it's going to be plus 6a. And 3a times -3a is a -9a squared. Right? Right. Linear terms. Remember, this is called a conjugate. Numbers are the same. The only thing that's different is that one's plus and one's minus. So you end up with 4 minus 9a squared. It's the difference of two squares. Now, what if we put an I in there? What if we have 2 plus 3i times 2 minus 3i? Again, we did the distributive property. 2 times 2 is 4. 2 times -3i is -6i. Now we do the same thing with the 3i. 3i times 2 is a stupid, no, not that, plus 6i. And then 3i times -3i is a -9i squared. Why I squared? I times I squared. Middle two terms are eliminated because they're conjugates. So this is going to be equal 4 minus 9I squared. Now we know the value of I squared is negative, excuse me, negative 1. So we have 4 minus 9 times negative 1, right? I squared, negative 1. So this equals 4. Now we have minus 9 times negative 1 is a positive 9. So our answer is 13. Right? Remember, always look for the conjugates because these are going to help you out. They're very, very helpful. 4 plus 7i. I know I'm going fast. I'm sorry, but you can stop and start as you well know. And 4 minus 7i. Because I only have so much time on this recording here. Take a drink. 4 times 4 is 16. 4 times negative 7i is a negative 28i. Now we do 7i times 4 is a positive 28i. And 7i times a negative 7i is a negative 49. Middle two terms cancel each other out. Any number minus itself is 0. So we end up with 16 minus 49. Oh, look at what I did. I'm so stupid. This is supposed to be negative 49i squared. I'm sorry. Because I times I is I squared. So 49 times. Now I squared is, we know, negative 1. So we have 16. Negative 49 times negative 1 is a positive 49. And 16 plus 49 is 65, I think. Something like that. Okay? Let me do one more. Negative 3 minus 2i times negative 3 plus 2i. This is a conjugate. Remember, the numbers are the same. Negative 3, negative 3. Negative 2i, positive 2i. The only thing different is the sign is different in the second number. So we do negative 3 times negative 3 is a positive 9. Negative 3 times 2i is a negative 6i. And negative 2i times negative 3 is a positive 6i. Negative times a negative, positive. And negative 2i times 2i is a negative 4i squared. Middle two terms are the same, so they're opposites to each other, so we cancel those out. So we have 9 minus 4 times, and remember, I squared is negative 1. So this equals 9 plus 4 is 13. Okay? You are going to see a couple of these on the final exam. Yes, solving quadratic equations. This is real simple. Very, very easy. So if you have this, if you're given that you want to find the solutions to this, x squared plus 4x plus 3 equals 0. We want to factor this thing. Excuse me. What are the factors of 3 that add up to 4? We know it's going to be x plus something and x plus something because all of the terms in here are positive. So what are the factors of 3? 1 and 3. 1 times 3 is 3. 1 plus 3 is 4. So we're correct. Equals 0. So all you do here is you take each factor and you set it equal to 0 and solve it. So you have x plus 1 equals 0 and x plus 3 equals 0. Subtract 1 from each side, so x is negative 1. Subtract 3 from each side, and x is negative 3. These are the roots of, or the solutions to, roots, zeros, solutions, all mean the same thing. Let me take one of these and plug it back in here, and we'll prove to you that. So I have x squared plus 4x plus 3 equals 0. So wherever there's an x, we're going to plug in negative 3. So negative 3 squared plus 4 times negative 3 plus 3. Does that equal 0? Negative 3 squared is a positive 9. 4 minus 3 is a negative 12 plus 3. Does that equal 0? Yes. 9 and 3 are 12. 12 minus 12 is 0. Or you can go 9 minus 12 is negative 3. Negative 3 plus 3 is 0. So we are correct. And you can do the same thing for negative 1. Go right ahead. But I ain't doing it. Okay. Everybody get the idea there? Oh, I'm sorry. Sorry. I'll do better. No, I'm not going to do any better. Take a drink. Mm-hmm. Okay, what if we have this? X squared minus 16. What do we have here? A beautiful little conjugate, right? The difference of two squares. This is a perfect square, and that's a perfect square. So this can be factored into x plus 4, equals 0. X plus 4 times x minus 4 equals 0. Set each one of these equal to 0, so x plus 4 equals 0, and x minus 4 equals 0. Solve this, you get x equals negative 4 and x equals positive 4. Plug this back into here. 4 squared is 16. 16 minus 16 is 0. And if you did with the negative 4, it would be exactly the same. Okay? Okay. Okay, what if we have this? What if we have b squared equals negative, come on, stupid, think, 9. Remember, the first thing you want to do is to set this equal to 0. So this is going to be, I'm going to add 9 to each side. B plus 9 equals 0. Is this a conjugate? No. Remember, conjugates have to be the difference. Stupid boy. That was a square. They have to be the difference of two squares. So what is our answer here? It's prime. Cannot be factored. Right? Right. Okay. What else? evaluating. Rational expressions. Who comes up with these words? Lord. Okay, so what if we have this? If we have 2x plus 5, and you want to evaluate it for x equals 3. Now, all we do here is wherever there's an x, we're going to plug in 3. So it's 2 times 3 plus 5. So that is, now it's order of operation, or you can put it in your calculator and it'll spit out the answer. 2 times 3 is, was it 6? Plus 5 is, let's see. Am I out of focus here? Is that more better? Okay. They get a little bit more, not really more complicated. They just get longer is all. If we have this, if we have 3x plus 6 over 2x minus 4, evaluate for x equals 0. Okay, and again, excuse me, and again, excuse me, wherever there's a 0, bonehead, wherever there's an x, we're going to plug in 0. So it's 3 times 0 plus 6 over 2 times 0 minus 4. 3 times 0 is 0. We have 6 over 2 times 0 is 0, negative 4. On the final exam, they may give you one of these, but be sure and reduce the fraction. So this is going to be negative 3 over 2. And remember, the negative can go anywhere. It can be negative 3 over 2, 3 over negative 2, or it can be negative 3 over 2. It doesn't make any difference where the negative goes. Okay. Now determine determine when it's undefined. If you have any number with a 0 in the denominator, this is undefined. Okay, you cannot have 0 in the denominator. This is semi-important. So what we want to do is we want to find out if we have, excuse me, a 3x plus 6 over 2x minus 4. Find out what the value is that will make this undefined. What's the value that will make this whole expression undefined? It's real simple. All we do is we take the denominator and set it equal to 0 and solve it. Add 4, 2x equals 4, divide by 2, x cannot equal 2. If you put 2 back in here, 2 times 2 is 4, 4 minus 4 is 0, and like we said, we cannot have a 0 in the denominator. Okay, so set the denominator equal to 0, solve the equation. Now what this says is 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. Negative 5. Okay, so if you were to graph this, what would this look like? 2 is right here. It cannot equal 2, but it can equal any other number plus or minus. Okay. Oh, that's all. All right. Y'all have a good weekend. Thank you very much. Bye-bye. Bye bonds. Um, make sure I've got your Visa card number so we can charge you for this. No. Y'all be good. Take care. Bye-bye. Bye bonds.